Hello all, let's talk about a simple boost converter design. So in this design, we will just build a sample boost converter without too much of design calculations put into it. So we will talk about the design calculations after understanding the functionality of this particular circuit. So the boost converter we know, right? Output voltage is greater than the input voltage. That means if you want a higher voltage than the supplied voltage in your circuit, you use a boost converter. So how it functions is mm, basically when this MOSFET is on. Okay, so this particular MOSFET is a switching element in the boost converter. So when this MOSFET is on, what happens is this particular voltage, the DC voltage, charges the inductor, and then the entire current flows through this because there is a ground. And when this is off, what happens is the current flows through the inductor through the diode. The diode will be reverse biased, and then it charges the capacitor and parallelly supplying the current to the load. So that's how the simple operation of push converter is. Basically, it's like what happens is when you have this MOSFET off, the output voltage is sum of the input voltage plus the voltage across the inductor. So that's how you get the boosted voltage at the output. Simple way to understand this circuit. So, considering this scenario, the design criteria for these boost converter involves selecting the inductor, selecting the MOSFET, and also selecting the duty cycle of this particular MOSFET gate voltage. So that based on the variation of this duty cycle, the MOSFET switches, and then the diode basically, which helps to isolate, and the output capacitor, which helps to sustain the voltage. And this particular capacitor is very important because when initially, as we said, when the MOSFET is on, that means a very initial condition when the power is on, then at the inductor gets charged, and when this MOSFET is off, the capacitor gets charged, and again in the next cycle, when the MOSFET is on, that means the entire current flows through this MOSFET. The output capacitor must have sufficient energy to supply the entire current that is given that must be provided to the load. That means the load current should be provided, and we should not have any issues with respect to the operation of the load. So the selection of the capacitor is also very crucial. So while doing these boost converter calculations, these are all the parameters we do, and also during those calculations we also calculate the maximum resistance. So now that we understand what are all the different design elements that we need to consider in boost converter, let us try to simulate this as is. We haven't put any thought into design, just randomly selected the components, and even we are unsure what is the output voltage of this because we haven't calculated anything. So, when we run this, uh, it's just getting simulated. So you can see here, this is the green is the input voltage, which is a 9 volts, and then we have simulated only till 1 second. So below this, we can ignore the output waveform. So you can see here there is output ripple. So again, that involves part of the calculation. You can see approximately, we can say around 19 volts is the output here. So for a given circuit with a MOSFET that is switched, if you go to the MOSFET and see, the gate voltage is switched at 50% duty cycle. So if considering that this is 1 kilohertz output, and mm, out of it 500 hertz is used for the um, for on period, and 500 hertz is the off period. So that's how we consider this. So now, um, let us assume I want a higher voltage. So to understand the operation of this boost converter, so we initially said that the output voltage, when it is supplied as the sum of the input voltage plus the inductor voltage, right? That means when these two gets added, that's how the output is supplied. So more you develop the voltage across the inductor, the higher the output voltage. That means more the MOSFET is on, the higher the voltage that is developed across the inductor. So when we say more higher, more time the MOSFET is on, that means the duty cycle, that means the on time of the MOSFET must be high. So considering that scenario, let's assume uh, 0.005, we make it 0.007, that means 700 H. So when we simulate now, okay, you can see here. Okay, right now, as we said, ignore the output ripple. You can see here the output voltage has increased. That means the operation of this boost converter is depending on how much the inductor can sustain, basically the output voltage, and then the duty cycle of this MOSFET. So the more the MOSFET is turned on, that means higher the duty cycle, higher the output voltage. So that's how we can control a boost converter. So you can play around with the duty cycle of the MOSFET to come up with the output voltage. And also in this diode, instead of this diode, some people might use another MOSFET switch as well. So that's another configuration, so which works in sync with this MOSFET. So that's how it can be designed. So as was said, and another important point is that this ripple current has to be defined, ripple voltage, basically ripple voltage has to be defined beforehand itself, and the design happens based on that criteria. So that's another important parameter in the boost converter design. So what we try to do here is, we just try to inculcate the design parameters of the boost converter by using a simple circuit and playing around with that circuit. We will talk in detail about each and every calculation associated with this. So it is clear that if you have a simple circuit like this, you can definitely build a boost converter. Hope we gave some clarity on boost converter design and helped you to understand the parameters associated. Please let us know if you have any questions. Please post your suggestions about our video. Please like and subscribe our channel. And if you have any other points to discuss, any other observations you had with respect to your mm, designs that you have worked on boost converter, please do post on our channel, which helps others to understand. Thanks for watching.